In this video, we will discuss about logical constraint and reified constraint. What is it about? This is something that we needed to model the problem of the stable matching problem, but probably you didn't notice it. So in that specific line, we are testing if this value is less than this variable, because you see that this was an element constraint. So that's a CP variable and that's an integer. Okay, and then we have an implication there. So this whole expression there is reified as a Boolean variable as well, and then we involve that Boolean variable in an implication there. But to do so, we need a constraint of this form. This Boolean variable is true if and only if this variable x is less than the value v. And we will call that the is less or equal constraint. You see that we have the Boolean variable, the variable x, and the value v that we are testing if it is less than or equal to this value v. So in the post method, there might be different propagation directions. First, if the Boolean variable is true, if it is true, then x must be less than v. So if it is true, then we remove all what is above in the domain of x, all what is above the value v. If b is false at the time of the posting of the constraint, then we remove all what is below the value v plus 1, because in that case, it must be in the other direction. So x cannot be less or equal to v. It means that in that case, x should be larger than v. Okay, and so that's this direction. Then what can also happen is that the maximum of x is less than or equal to v at the time of the posting. In that case, we fix the value of b to 1, or if you prefer, to true. If the minimum of v is larger than, if the minimum of x is larger than v, then we say that it's false because it's impossible that x is less or equal to v. Okay, that's all the possibilities when you realize that one of the two variables or the situations are detected at the time of the posting. In the other case, it might happen during the search or during the fixed point computation, and I will use here a callback mechanism, okay, and I will hook up this code to the event of when b is fixed on when the domain of x changes. So when b is fixed, if it is fixed to true, I remove everything that is above v. If it is fixed to false, okay, that's this direction of the propagation, I remove all what is above, all what is below v plus 1. And when the bound of x changes, I'm doing exactly the same check as here to detect if I can possibly fix the value of b to true or fix it to false. Okay, so this Boolean expression there that you see is really implemented. It's translated into a constraint as this one with 3 arguments. The first integer, the variable there, and the Boolean truth of this expression less or equal. Then you can also implement the implication there between 2 Boolean variables with these 2 less than or equal expression. Okay, we also need that implication there. Okay, how do we translate this implication? Well, the first thing that you should remember for the implication is that b1 implies b2 is the same as not b1 or b2. Okay, and that one is also the same. If you prefer, you can translate that into a sum like 1 minus b1 plus b2 larger or equal to 1. And that can be easily expressed with views, with sum, and with basic constraints. Okay, so the first step, we verify these 2 constraints. We get 2 Boolean variables, and then these 2 Boolean variables, we transform them as a sum expression, a sum constraint, such as this one, and we are able to model this very complex logical expression for the stable matching problem. Okay, and so in MiniCP, we have the post of a Boolean variable because the whole expression there will be reified as a Boolean variable. And so if you post a Boolean variable, we fix it to true. We want the whole expression there reified by this Boolean expression to be fixed to true. Okay, and this way you can really post arbitrary logical expression easily in MiniCP. And this is what you will do in the programming assignment about the stable matching problem.